Techie Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines using the Solid Edge software. Coming to the problem statement. The top view of a line 75 long measures 50 The end P is 30 in front of VP and 15 above the HP. The end Q is 15 in front of VP and above HP. Draw the projections of the line and find its true inclinations with HP and VP. So, after having read the problem statement, we can arrive at a set of conclusions, and those are the true length of the line is given, and the true length is 75 So, this length should be the same in both the vertical plane as well as the horizontal plane. And also, the top view of this line measures 50 Suppose if I consider this line as PQ, the true length of the line PQ is 75 and its top view, that is the small p and q, measures 50 that is the view that we get in the horizontal plane. And the end point P is 30 in front of VP and 15 above the HP. The end Q is 15 in front of VP and above HP. So this is the data that is given to us. So keeping this contents, we need to draw the projections of the line. So we will begin with selecting the line option and drawing a xy line of thickness 0.18 So let us draw a line of any arbitrary length and annotate this line as x and y, and also annotate the reference planes as VP and HP. So this indicates that the line is in the first quadrant. So now we will draw the position of the point P. So he tells that the point P is 30 in front of VP and 15 above the HP. So we will locate the front view of the point P as 15 above HP and also 30 in front of VP. So this is the top view of the point P. So this is P dash P prime, and this point is P. So now let us draw the locus of this particular point. So consider a line of thickness 0.13 and let it be a dotted line. So this is going to be the locus of the line P in the vertical plane and the locus of the line P in the horizontal plane. So let us annotate this line as locus of P in the vertical plane and this line as the locus of P in the horizontal plane. So now this is about the point P. Now he also tells that the end Q is 15 in front of VP and above HP. So he is not given the end distance, that is the distance between the end projectors, that is P and Q. But however, we do know the details of its true length, that is 75 So with this data, we shall see how to do the projection of the line. So first we will locate the endpoint Q. So first we will try to do the locus line of this endpoint Q. So it is at a distance of 15 So for that purpose, I'll select the XY line and offset this XY line to a distance of 15 and this is in this direction because it is 15 in front of VP. So let me change this line. Okay, so let me annotate this line. So this line is the locus of Q in the plane, horizontal plane, that is HP. So this is at a distance of 15 So somewhere here only I'll be having the locus of this endpoint Q. So this is the locus of Q and here only the endpoint Q will be located. So now keeping this data, now we will see how to do the rest part of the problem. So we do know that the top view of the line measures 50 So the top view, so I'll be selecting the thickness as 0.50 and then so the thickness is 0.50 and the length of the top view is 50 So somewhere here, if I just try to draw the line, it is going to intersect with this locus line and this point will be Q. So this is the top view of the line PQ, which is going to measure 50 as per the problem statement. And we also know the true length of the line. So the true length of the line is 75. So we will draw the true length of the line, taking the thickness is 0.13 from the point P. So this should also lie somewhere here on the locus of Q. The true length is 75 mm. So it has to lie on this locus of Q, and this completes the true length of the line. So let me annotate this point as Q2. So this PQ2 is the true length of the line PQ when it is inclined at a given angle to the vertical plane, and PQ is the top view of this line PQ2. So this is the apparent length and this is the true length. So now we do not know the data here, but we do know that the true length is 75 mm. So now keeping this in mind, so let us try to complete the problem. So from the end point of this line, I will be making it parallel to the xy line, and I will be representing the front view of this point Q2 on the locus of P. So this is P dash Q2 dash. P dash and Q2 dash represents the front view of the line PQ2. So now keeping this particular distance, so I can just draw this also to be a continuous line. I'll select the tangent arc, under that arc by center. So let me draw an arc of radii P dash Q2 dash. So I'll just draw an arc of a particular length. So the radii should be P dash Q2 dash, and it could be of any angle. So this arc has to intersect the locus of Q in the VP, but we do not know where the locus of Q is going to lie. But I do know that the locus or the projector from Q will be having its front view on the locus of Q in the vertical plane. So keeping this concept, I can draw the projector line. So from point Q, I'm going to draw a vertical projector line. So this point is going to indicate the presence of the point Q dash in the front view. So keeping this as the reference point, I will be drawing the locus line through this point of intersection of the arc and the vertical projector that I've drawn. So this is the locus of Q in the vertical plane. So let me annotate this line as locus of Q in the vertical plane. Correct. So this point is got, so this point will be Q dash. So now I'll select the line option, change the line type to continuous line, thickness to 0.50. So P dash to Q dash is going to give me this apparent length of the line in the front view. Correct. So we can just measure the length, and this is going to be 73.48. So this is approximately 73 mm. So this is the true length of the, so this is the apparent length of the line PQ in the vertical plane. So now we got to know that this is the apparent length of the line in the front view, and this is the apparent length of the line in the top view. Correct. So Q and Q dash, they will be having the projector on the same vertical line. So now we need to mark the true length of the line, that is P dash Q1 dash in the vertical plane. So for that we will follow the procedure of drawing the locus, or taking this particular reference line, that is the apparent length, and then completing the locus line here. So we'll just see how it can be done. So let me select the line option, and let me draw the true length of the line. So that is 75 mm. So it is going to intersect the locus of Q here, and from here, okay, I haven't changed the thickness of the line. So let me select this line, change the thickness to 0.13. Again select the line option. So from the end point of this line, draw a line parallel to Q, So change the thickness to 0.13 mm. So this is PQ1. So this point is P dash Q dash, and this point will be PQ P dash Q1 dash. So P dash Q1 dash represents the true length of the line PQ when it is inclined at a given angle or the true angle to the HP. Correct? So from here I've drawn the projectors, and it is rotated until it becomes parallel to the locus of P. So I have to extend this line. So select the extend to next option, and then I'm going to extend until it is meeting the locus of P. And this point will be, so this length will be equal to PQ1, which is the top view of the line P dash Q1 dash. So this is PQ1, this point. Correct. So now let me select the arc by center point and draw an arc of this radius PQ1. See here, you can just see that it is going to pass through exactly the uh, top view of the line that is given to us, which is 50 mm. Correct. So you can just see that the problem that we have done is correct. So we are just following the procedure. So first we did the true length of the line in the VP and the HP, and then drew the projectors. So using this particular data, we understood that the point Q is going to lie on this locus line Q, which is at a distance of 15 mm in front of VP. Correct. So this is the uh, strategy that we have to use to solve this problem. So the data given to us is the top view of the line, which is 50 mm, and the true length, which is 75 mm. So to measure the inclinations, this line and this line, so this is the value of alpha, and this line and this line is going to give us the value of okay, this is the value of theta, that is the true inclination. Alpha is the apparent inclination. Similarly, selecting this line and the locus of P, so 17 degrees is the value of beta, and similarly this line and this line, so this is going to give us the value of uh, alpha. This is the value of beta, which is 12 degrees. So 17 and 12 degrees are the values. So 50 and 48, 17 and 12 are the true and the apparent inclinations respectively. So 50 degrees and 17 degrees are the values of the apparent inclinations, and 48 degrees and the 12 degrees are the values of the true inclinations. And then measuring this length, so this is 50 mm and this is 75 mm, which is the true length, and here we have already measured the apparent length, and this is the true length of the line. So with this we complete the problem. So to sum up, the data given to us was the top view of the line, which is measuring 50 mm, and the apparent length was 50 mm in the top view, and the true length was 75 mm, and the projector of Q was given to us. So this is the location of the point Q. Okay, and we will just annotate the directions of the projection lines. So change the arrow color to black and click OK. So we have done the arrow from this direction, so we have taken the projector from this direction, and we have drawn the projector downwards, and then we have drawn the arc from this point to intersect the locus of Q. So with this we have completed the